Cloudsoft is a sponsor of our ebook on automation and orchestration in the Docker and container ecosystem. Learn more about Cloudsoft and its perspectives on these timely and important topics by downloading the ebook at thenewstack.io. Alex Williams, the Newstack, here with Alex Heneveld, co-founder and CTO of Cloudsoft.
Howdy, Alex.
Howdy, Alex, to you. How you been?
Very well.
Good. We're here at IBM Interconnect, and it's been another busy week on the conference circuit. And actually, I just had a conversation with Duncan, and we were talking a lot about autonomous computing. But before we get to that topic, I just want to set up this discussion, and this is for our ebook series on the Docker and container ecosystem, and so we want to thank you guys as sponsors of that. And in these interviews, we like to hear what your perspective is about the Docker and container ecosystem. But before we do that, perhaps you can tell us a little bit about Cloudsoft.
Sure. So Cloudsoft is the leading application management company. When we talk about management, we're really talking about understanding the shape of running applications, what they're doing across all of the different platforms, infrastructure, hardware, network systems that they run on. And we're seeing with Docker and containers and with Mesos and with Cloud Foundry a blossoming of the different platforms or substrates that applications run on. But that doesn't change the fact that I have an application that's doing this, that's built up from pieces. So if you can get that consistent view, then you can bring consistent management, whether you're running in a very traditional environment or running on the latest and greatest. And that frees you up to run on whatever's going to come next, which we just don't know.
So that really is an automation story. And this book is about automation and orchestration as a narrative. So really what you're talking about is an automation story, isn't it?
Yes. I think a big part of management for us is really let's get the automation in place, and actually kind of just before you can do management or good automation, you really need the modeling. And I think that's what differentiates Cloudsoft's approach. You may know we're the originators of the Apache Brooklyn project, still a lot of the contributors to that. And that's an open source project in Apache for being able to model and manage systems, wherever they may be, whatever they may be. People are modeling IoTs and networks, but a lot of the focus is looking after software.
So tell us about Apache Brooklyn, because it has been a foundation for what Cloudsoft has been talking about. Can you tell us about the technology stack itself?
Yeah. So it's founded on the ideas of autonomic computing. And if you don't know much about that, it's worth looking up kind of some of the history. It's fascinating. But the premise of it is, let's look at managing complex systems the way the most complex system of all does it, the human body. And the human body has various subsystems that are autonomic. That means they can look after themselves. If I had to sit here and think about every time I took a breath, or think about how I form the lips for how I talk, I wouldn't be saying very much, which might be a good thing, but probably not if we've got people listening. And so the autonomic system allows us to kind of break complex tasks into smaller tasks, subsystems that generally do what they need to do. And then in extremis, if there's a problem or some information that's needed in autonomic terms, they'll emit a sensor. And then there will be management above that that's looking after those sensors. The base pieces also have effectors in autonomic theory, and those are the levers, the operations you can do to change something. So it's this combination of sensors giving metrics, really, and effectors letting us control things that is sort of the encapsulation of a system. These want to be managed, typically by another system, that itself has sensors and effectors. Within it, it's doing the monitoring, analyzing, planning, and executing to take care of the systems underneath it. But you can almost view it like an org chart or a hierarchy. We sort of have a fairly looser than some very strict theories in this realm. But the idea is you can make very complex systems just by composing simpler systems. And if we look at what's happening around microservices, we're building up complex systems from simpler systems. So the idea of autonomics plays really nicely with the microservices. What we're missing in the abstract, and what Apache Brooklyn tries to provide, is the model of that. So if I'm tasked with a complex system, I can see what are the simpler systems within that. And if everything's working fine, I don't need to worry about it. But if something starts to go wrong, I need to be able to unpick the complex system and look inside it, go all the way down to the weeds, to the processes and the containers and the infrastructure, the VMs, the networks. I need to have all of that there, but most of the time I don't need it. Now, if I'm lucky and someone's hosting some of my substrate, I don't need to look that far. I just kind of go, and if I've got a hosted container service, for instance, I'm not interested in the plumbing underneath it, but I do want to know that every one of those containers is doing the right thing. So the metrics that we get back from each piece becomes absolutely essential to informing that model, allowing us to maintain a healthy system and correct it and improve it when it's needed, whether that's scaling or failing over or DR. And in our world, those are implemented as policies, or it's sort of where this monitor, analyze, plan, execute logic sits within the autonomic framework.
So, backing up a little bit, the Docker and container ecosystem is still relatively young, and we started talking, initially about containers almost as a unit, right? And there's been a lot of people who've been able to understand, been able to learn about how these units work. A lot of developers just use their laptops just to experiment with containers. But that has led to, as we well know, the ecosystem growing quite rapidly. And now we have any number of billions of containers out there that people are managing and operating. And so the complexity has changed quite a bit. How has that complexity changed in your view? And how are you viewing that complexity now?
Well, I sometimes think of it, containers are the new threads.
Yeah.
If we go back 20 years, we wanted to take advantage of multiple cores, and we wanted to be able to program in ways that we can have parallel threads of execution. When everything was single-threaded, life was a whole lot easier.
Yes.
But once you've got threads, life becomes a lot richer and more powerful. And now we'll routinely run thousands of threads on a system. It's just a nice way to encapsulate a chain of processing. I think containers are exactly the same. What we used to try to deal with as, put it in a process, put it in a service, in a tarball that will unpack. We now say container gives us a really easy encapsulation that, unlike all the VM appliances, are really fast and small. So they're quick to work with for the most part, with copy on write and booting without booting the whole OS. So we can now really encapsulate processes really in an OS type container, but with the speed of launching a new thread. And under the cover, sometimes that's exactly what it is.
Okay, so with the speed of a new thread, right? So now we have multi-threaded environments, so to speak, to use that analogy. And so those, what are some of the complexities that we're starting to emerge? We hear now more about the networking requirements and the software, and the new software requirements and the new storage requirements.
Well, we're used to thinking about sort of server hugging. And if you view a container as an OS, you might be tempted to want to hug that container. If you're trying to think of it as containers are like threads and we're going to have thousands of them, we're going to throw them away, you've got to stop hugging them. You've got to sort of put some sort of governance around them so they don't run amok,
right.
But otherwise let them do their thing. So again, autonomics comes in.
Right.
We've got sort of groups of them doing the right thing most of the time and checks in place to keep them from running amok. When we come to networking and storage, there can start to be contention with the underlying systems. If we've got thousands of different processes putting different demands on the storage in real time, there needs to be some policing around that. That is still something of a difficult problem. There's progress being made, but storage is always complex. To the extent where you can abstract that out and deal with a service who's handling the storage, your life often becomes a lot simpler. You can't avoid having a network in the mix, though, if your system's doing anything at all that anyone else might be interested in. And so network contention is a very interesting place. But there we've got more mature systems for setting up quality of service and bandwidth shaping around the containers.
Mm-hmm. So with these new these new complexities, what are you seeing customers asking about? What are they trying to do? What are some of the stories you're starting to hear about how they want to adapt their infrastructure? And I guess the question I increasingly was, why do they have to do it now? Or like, why does it matter? Why can't they just continue to like work in this VM environment that they have?
Very good question. There's probably a three-step process for that. And the first step, which is just so easy, let's treat containers like a cloud. Mm-hmm. Let's deploy some OSs. There are Docker purists who say you mustn't ever do that. And there's actually some kind of good philosophical reasons why you might stop doing that as you can mature and work in greenfield spaces. Mm-hmm. But for those of us who do spend our lives deploying systems that used to be VMs and waiting 10 minutes, a lot longer if it's a bad day, for a VM to come up, a lot of what we're doing we can push into container environments, and they come up in sub-second. So I think the step one is just let's use containers because they're so fast to boot. But the second wave is where we actually get encapsulation of processes. Because these containers can run so fast, why am I going to give you a tarball or an RPM that's going to have to go download a whole bunch of dependencies, might not run at the end of the day? I'll just give you a container that locks all that down in an OS, much more reliable, and due to some of the magic happening with caching and backend and hubbing and copying on write, it's a lot faster to download as well. Your container will be booted running before your apt-get has updated, even if your VM can boot real quickly. So the second wave is the encapsulation of whatever you need to run. The third wave, as I see it, is where you've internalized this and you're actually architecting differently. When you reach a point where we can launch containers really quickly, let's make containers part of the API. You want some function done, you don't have to write that in some language. You give me a container, and I can run it, and I pass something into that container, it does what it needs, it gives it back, job done. Amazon Lambda is a great idea. And it's when you get to that third world that every API call might be taking 5 containers, which are going to be run and thrown away. Now we're not really there yet, but sort of I think that's the trend where this is going. I mean, it is nothing now for an API call to run 5 threads. It's going to be the same. It's going to take 5 containers, launch them, throw them away, be done with it. And that's where we really need very good management around making sure we do have good balancing about where things are running. We do understand which containers are logically related to which other applications and systems, what they're doing, are they running well, which ones are orphaned, because the sprawl and the wastage has always been the curse. When we had physical machines, we'd have machines we didn't know what they were doing, cluttering up attics or basements or data centers. Then it becomes VMs, and we've got 1,000 times as many VMs. We don't know what they're doing, where they are, they're taking up space. And we'll see that happen again with containers. But if we put the right frameworks around it for knowing what these are doing from day one, then we can do a much better job at avoiding that.
So let's go through some particulars then, and this might help illuminate the larger story. So for example, how are you thinking about service discovery in these kinds of environments?
So many different ways.
Yes.
Increasing all the time. I've always loved DNS. And there's great DNS ways that we can set up service discovery. Great new tools at CD and Console, for instance. I think one of the challenges is getting the scoping right. Understanding how do we if we've got some services are available for some other people to discover, but other people can't discover it. Getting those partitions right and the access control, a lot of big open questions there.
Mm-hmm.
And I think that's not restricted simply to containers. I mean, that's as we move to a services ecosystem, we're thinking about service marketplaces, but there's a whole lot of permissions that we want to lock down around who can access those services. We see the same thing in the Cloud Foundry world, where there's permissioning around services. And I mean, again, the frameworks, the requirements, the constraints, it goes back to the old entitlements challenges. And every big company has their own complex way of dealing with who can do what. And there's probably no way around putting the same thing in place with services. Service might be the employee data, payroll data. We've got to define who's allowed to see that and who isn't. And the challenge doesn't go away.
This is where it gets interesting to me because I had a conversation, a few months ago, and the topic turned to microservices, and and I asked about this question of managing this complexity in essence, and like how do people understand how to do things in these microservice environments, and it reminded me of you guys because this person talked about manifests, right, and talked about essentially instruction sets, right,
Mm-hmm.
and you guys talk a lot about this idea of blueprints. Correct?
Absolutely.
And there's a corollary there to services, correct? And microservices and these frameworks. And that to me helps kind of understand who you are, right? Because you have this very kind of sophisticated platform. You're using Apache Brooklyn, and you also have Clocker, which we can get into, which is essentially a scheduler, correct? Well,
no.
Not really. No, it's Clocker we can get into it.
We can come on to that.
Yeah, because I get these things mixed up myself. But we have you guys have the Apache Brooklyn environment, but as you say, these systems get increasingly complex, and then at that point, because of this complexity, why do you need blueprints? What is the importance of blueprints, and how do they relate to automation, orchestration in that container context?
So let's go back to the thread analogy, and let's say I had a complex app with 100 threads. And let's say I had no way to see that these 100 threads are part of the same app. They were just started 100 threads. That application would be impossible to manage. You'd have to kind of go reverse engineer, okay, that thread was started at that time, and so he's probably part of this system. If we're not careful, we see the same thing with VMs and containers. A whole bunch of containers might be launched at around the same time, and we can guess that they're part of the same system. If I'm smart, I might have some naming convention around them, so I can do some backtracking. With Brooklyn, we try to turn that on its head. Let's actually start with a description of what we need, which is what the application is doing in the multi-threaded world. The application then drives the threads. The blueprint will drive the containers or the VMs or the new tenants created in services. And so in our world, the blueprint is really the description of the application that we want to build. It's a pretty simple YAML format. If you look at the Apache Brooklyn site, there's a nice blueprint tour that kind of walks you through a whole bunch of the features. Stick some shell in there, reference Docker image, use salt, pick your poison, make web calls if it's a REST endpoint that you're hitting. All of these are supported. But what happens is we then go and provision all of those, containers, VMs, bare metal, processes, REST calls, S3 buckets, you name it. The application can create those. And what Brooklyn will do is maintain thereafter the live model of everything that got created. Where it gets really powerful is that I can then I'll create a blueprint to stand me up a Cassandra cluster. Well, you can then take that blueprint and reference it and say, right, I'm going to build a richer app that's got some Node here, some Cassandra here, and some Spark there. So I'm going to take those three blueprints, piece them together, and that's my system. Or your system, rather. So now, whereas my system might have just been the three containers for Cassandra, or the three VMs,
right.
Your system is now gone up to 20 because you're kind of building up all these pieces. And then you might have some elasticity in some of those tiers. So But you got it really easy because you just had these composed blueprints. And at runtime, you've got that modern analog of the dreaded CMDB, the config management database. But the inventory of everything that was created for that application, containers, VMs, other services. And if you want to stop it, most of our blueprints come with a stop effector. So you stop yours, that tells Cassandra to stop, it tells the Node app to stop, which in turns decommissions the VMs, kills the containers, stops the processes, destroys the bucket. And so it can clean up after itself. So while it's in life, you have the easy ability to audit, see who created it, where is it running, what's it doing. You look at a container, you know who does it belong to. But then when you want to get rid of it, there's a nice package way to do that.
Okay.
That probably makes autonomic computing and management, which sound quite vague, a bit easier to understand.
Yeah.
Start and stop are operations, effectors in our world.
And so you can do this with VMs, you know, and you can do this with containers, right? And with containers in this automation and orchestration environment, now we have a multiple, right, effect. And with that multiple effect, then that seems to make the autonomous computing story more relevant, doesn't it?
Just because we're going to be starting to operate at such a larger and larger scale, more rapid turnover of the creation and destruction of these containers, we want to make sure we've got good management around it so we know exactly what's running. So you mentioned Clocker earlier. So
yeah.
Clocker is nothing more than a blueprint to create a whole bunch of Docker engine hosts. So if I want a 50-node Docker cluster, I can then run 50 million Docker containers in there. We'll treat that as a blueprint, create the VMs or work on the bare metal. We can put auto scaling on it, so we can bring some more machines to that, install Docker on it, have it join the clusters, set up the swarm endpoint. And people can consume it just in the normal way through the swarm endpoint. And so Clocker is really giving us that managed blueprint for a container service. But the flip side of that is that once we have this, we can deploy into that container service in the same way that we would take our Cassandra blueprint and we could deploy it into OpenStack. We can take it and deploy it into this container service. You give me a Docker Swarm endpoint, you can push it, and we'll create the VMs, create the containers with Cassandra running. The only difference is that whereas it did take 20 minutes to get it running, it now takes 20 milliseconds to boot, maybe another few seconds for the cluster to stabilize. You've got your cluster there in 3 seconds. And that is a day and night difference.
Mm-hmm. So a lot of, this is a time of almost peak confusion, as Brian Cantrell would say. And people hear a lot about, these different environments. How is the Cloudsoft environment different than, Kubernetes or Mesos, or what's the overlap there, and how do you support these different environments?
So we have a lot of support for Mesos as a target.
Mm-hmm.
I think the real difference is that whether it's Docker or Cloud Foundry or Mesos or Kubernetes or Hadoop, these are all platforms which are good for quite large classes of tasks, but they're not perfect. I mean, I sort of think of it as if that's the ground that I'm deploying something onto. In the old days, the ground was the servers, physical machines. Then we got virtualization, then we got cloud. Okay, now I'm just going to deploy something in the cloud. Now we have these platforms that are even easier and faster to work with. I can deploy something into the platform. But it's got to fit the platform. With Apache Brooklyn and the Cloudsoft approach, it's more top-down. We want to serve the application. So you describe your application and we want to deploy it. We don't tell you how it needs to be deployed. You may have a very valid reason that containers are just wrong. For Cassandra, they may just be wrong. Mm-hmm. And so we can put it into the VMs, or we may have physical servers. But what that allows us to do is blend it, so we can put your Cassandra into some physical machines. We can put your node into the containers. We can put your RabbitMQ into VMs. And we can use an S3 that is provided as a service somewhere. And your application can consist of all of these. So instead of being opinionated, a platform specialized that you deploy onto, Cloudsoft is just a blueprint and a model that helps you as from the application and the operator work with these platforms.
Okay, so that's a differentiator, and like that helps understand kind of the differences between these different platforms and infrastructure, so to speak. It seems increasingly that we're moving into this world where there's what is the platform and what is the infrastructure anymore?
Yeah, well, the platform is infrastructure.
Yeah.
It's what I'm deploying to.
Yeah.
And containers are great because they make things faster. I love Cloud Foundry for the same reason. It's easier for me to work with in certain conditions, but it's not the answer to everything, and it's certainly not the answer to the question, what does my boss care about?
Mm-hmm.
What do my customers care about?
So
they care about my applications running.
Right.
So the infrastructure and the platforms are just a means to making that easier. But where we say the focus needs to be is on the application. Let's get good management and modeling around that application, and then in some ways we're future-proofed. We can run in containers today, we can run in Mesos tomorrow, we can run in the next thing after that, and if the auditor comes around and says, oh no, you're not compliant, you need to run in this really awful environment that's safe, we can do that too. So you've got that portability. Mm-hmm. And what a lot of people are doing is actually using containers to test their blueprint, and during the dev test, they'll spin up the complex environment they need. But when they move to production, things might be deployed onto VMs or physical servers, or they might just connect to existing ones. So if I'm working against a payroll database, in dev time, I'll just stand up a container that's a payroll database. When I go into production, we've already got one, so we need to connect to the existing. And the blueprints can accommodate that. The same blueprint, you just tell it which mode, and it does the right thing in each.
So there's a Yevon test use case.
Well, absolutely. For
right.
What's an application? If an application hasn't been developed and tested, it's not going to work very well.
Right. So there's obviously that. The user is facing ever more complexity, right? Like in trying to figure out what to do. Mm-hmm. They're running their applications. They've had traditional CRM applications. They've had traditional ERP applications. They run those on VMs. They may even run them on a mainframe, right? Mm-hmm. Now they're like having to compete more in a much different kind of a market now, and they have business needs.
Yeah.
Right. So there's business cases for business use cases for working faster for these companies, but now they enter into this new world, and it's like there's the choices are just the complexity is just incredible. Mm-hmm. How do you thinking about what you guys do and thinking about your own platform and what Cloudsoft does and Apache Brooklyn, and thinking through how Clocker works and how it integrates with kind of these multi-cloud environments. What do you say to these people? Like you say, about where you start, or just how do you begin to think about a reference point to use to think about what direction to go in.
One of the best pieces of advice I was given about kind of architecting system is to think about death. Because everyone thinks about what's going to be the best way to run my system now. Mm-hmm. And actually what that misses is what's going to be the best way to kill the choices I made now in favor of something much better that's going to come along in 3 years. Mm-hmm. And if you architect well, you got a lot of modular pieces, and I can say, right, that piece that I wrote in Grails 5 years ago running on a VM, I can today use a REST API in Node with an Angular front end. And in 4 years' time, I can use some fancy 4GL that supports iOS and all sorts of the others that doesn't exist today. If I make it too big and I've got some monolith, which a lot of systems are in, my choice is just, right, kill what I have today and build something new. Whereas if you can build it with these modular pieces, then you're not locked in too much to any one design choice. Now, where that introduces the complexity is I've then got to put all of these pieces together. But that's where the blueprint makes your life much easier. So I think the advice in turn I'll give to people is, right, let's think about the architecture of your application. Start with the blueprint for that and make the simplest pieces in each that work, and then iterate from there. And that's true for Greenfield, but it also actually works for Brownfield. If I've got some complex legacy system, let's build a blueprint that represents it. And now let's pick the low-hanging fruit so we can migrate, say, the web tier is a good candidate. We can migrate that to run in containers or run in the cloud or run in Cloud Foundry. Making sure we can reach back into the data services that are going to be a little bit harder to move. Then with the blueprint, we can then start to tackle some of the data services. How do we replace like for like, or like for similar enough? Because one of the ideas, when you built your blueprint that we talked about earlier with your Node and your Cassandra and your Rabbit, if that's modular, you should be able to swap out RabbitMQ that you deploy for someone who's giving you Rabbit as a service or Cassandra as a service. And if you do it really nicely, then you should be able to swap out Rabbit for something else that talks AMQP or whatever message protocol is expected from your front end.
So this speaks to the ephemeral nature, doesn't it?
Yes.
Of people and how they need to work, right?
Yeah, and we're under so much pressure to get something out quickly that we often lose sight of the fact that 90% of the cost is going to come from the maintenance in many cases. But that doesn't need to be the case. I think if people architect with containers, you can get things running really quickly. And actually the benefit of the blueprint with containers is that you can build that complex structure in less than a second deploying to a container environment, so there's no loss of complexity. And in fact, the blueprint makes your life a lot easier because you don't need to start these 38 containers. You start the one blueprint. He starts the 38 containers. And we've all been in the movie where we started them and then we had to stop them. You don't have to go around and find those 38 and stop them and then look at, oh, we missed one from earlier. We just tell the blueprint to stop and it takes care of that.
And that speaks then to why you need to have a capability to manage the policy as well, right? And that's where then the concepts of the autonomous system comes into play, and the concepts of Apache Brooklyn.
Well, the modeling and the management is a very powerful piece of Brooklyn all on its own.
Yeah.
So I would say actually, if you're thinking about getting started, start with that.
Right.
But what really quickly happens when people are running in these dynamic environments is that we don't just want to start something up quickly, we want it to respond to changes quickly. And often people think about that as scaling out, and that's sort of one of the policies that we have. Let's scale out, scale back. But there's tons of others. Wide area is one of my favorite. If we can look at time of day and say, oh, actually, a lot of the demand for our service is now coming from Asia. Let's actually spin up something in Asia. Let's make that the master, and the other things will be the replicants, so that the majority of our users get the quickest possible experience. That's sort of a follow the sun type policy. Or follow the moon. I've got massive compute. Let's just go where it's cheapest.
Right.
And figure out, okay, is it actually worth shipping the data over there? And often, actually, I can get something half the price for 8 hours. It's worth paying to ship a gigabyte of data across for those 8 hours. And that's the follow the moon type policy. So where you get to when you have Brooklyn giving you that same model that we talked about using for starting and then stopping, we can use that model for scaling. We can use that model for DR. And that's where the policies come in. So within the blueprint, you can attach the policies. Give me an autoscaler that's running on the node tier. and that autoscaler will make sure that the load balancers get updated or whatnot. More interesting work we've done with Basho, take a React cluster, want to resize it. Well, there's a little more to it than just creating another one and updating load balancer. There's a whole join cluster, make the plan, commit, ship the partitions. You don't do it lightly, but if your disks start to get full, you absolutely do it. So let's have a policy that will scale out the React cluster when the disks start to get full. And very simple policy to add to a cluster. We've got the blueprint for the React cluster. And so you start to get these modular building blocks within the autonomics world, where the same policy that scales up one thing can scale up another thing. They're just listening to different sensor metrics on the way in.
So you talk about, for example, spinning it up spinning something up in Asia for application, so you can have the best application performance, whatever reason that might be.
Yeah.
Right. There's lots of choices people have, and we're hearing more about, the concept of like the distributed infrastructure, right? So you have this multi-cloud, environment. So maybe it's AWS, for some particular service. Perhaps it's, you're running something else on, software, and maybe even on your own data center environment, and so on and so forth. That raises lots of different kinds of complexities, doesn't it? So, like, for example, the first one I think about is networking, right? What are those networking complexities that those people have to think about? Because containers now, you can have so many more containers running, right? And you have this networking environment, which the traditional infrastructure environments with those traditional networks were not designed to do.
To be honest, I think often these are concerns that ought to be addressed by different teams. If I'm building the complex application, in an ideal world, I'm deploying that into a set of environments that have a good enough network.
Okay.
And I think in the majority of cases, that's going to be true. If you're with a company, you may have one or two cloud providers. If you've got a public and private system, you should have some sort of secure interconnect. You're absolutely right. It's too much to try to solve all of those problems at once.
Yeah.
If you are in a situation where you're running this in the public cloud, and you do want to be in several jurisdictions, there's still a couple good options. Some of the clouds, like SoftLayer, will actually give you a private interconnect between them, so you can have a private network visibility within different regions. So a lot of the problems go away there. The other thing we've done within the Clocker world, Clocker supports Calico as a plugin for the SDN, and again, it tries to solve the problem for you. So if you're running Clocker with Calico, we can stand that up in lots of different public clouds, but we use Calico to set up an interconnect between those. Your containers all see each other. They're all running on a secure private network, and they can be opposite sides of the globe, totally different clouds. They're going over the public internet, but they're encrypted the entire way. Mm-hmm. And from your application's point of view, you got a pretty simple flat network. Mm-hmm. If you want to do more interesting things with your networks and set up lots of different secure isolated ones, we'll do that too. But sort of think of that as a step 2 or a step 3. If the blueprint is written with these modular pieces, the way we deal with networking is pretty easy. We say that these modular pieces need to be in separate isolation zones. And it might be a security group, it might be a VLAN, lots of different ways to implement it, but the important thing is that it's isolated, it's impenetrable except for certain access points to certain other permitted modules in our system.
So thinking again about the challenges that people face, and we've gone through the example of why blueprints make sense, right? In a container context, especially and how Cloudsoft thinks about that. We talked about how these environments are meant in many ways to abstract that complexity that you would normally have to do in these multi-hosted kind of worlds. I guess I would just kind of like to conclude is uh, with what your guys' thoughts are about, how this, how your technology is going to be evolving over the next 6 to 12 months as, as these container environments do become increasingly complex. Container networking is just, is still really, pretty much on the edge, right? We're not really hearing, that's just a conversation we're just starting to explore.
Yeah, although the work that's been done with Clocker and Calico is plenty good enough for our pretty complex needs. We want to be able to stick things in isolation zones and set up some wide area interconnect. So it's possible. It's only going to get easier, which is a good thing. In terms of our focus, networking is still a big focus. And in fact, what's exciting is that some of those same networking capabilities that we can get in the container world, we're now starting to see in a lot of the clouds. OpenStack Neutron is much stronger. Amazon and Azure and Google Compute all give us quite nice networking constructs now. So we're in a world where some of the networking challenges or almost impossibilities a few years ago, where we wanted to have this strict isolation, we can now have. So implementing that is one of our focuses. The other two big areas one is reliability, and that really translates to a test framework. You write a blueprint within Brooklyn. There's called the test framework. You can put a whole bunch of assertions right there in your blueprints that will either in the actual blueprint assert that things are healthy, or more interestingly, in a much richer test case, assert that I took the blueprint that I wrote and now I've scripted a whole bunch of scenarios. If I deploy JMeter or some type of load engine and it generated this much load, then I observed this happen. And then if I go and I shut down the database, I see this happen. And you can script basically what we've always done with unit testing. We can now bring to CI testing called blueprint testing. And that's nice because it means that all of the blueprints get much more robust. Within Cloudsoft AMP, that's taken up one level where you can script a whole bunch of environments to run that against. So we can ensure that our blueprint is running nicely in 8 clouds across 4 OSs. And we run that anytime a change is pushed to an upstream dependency. We automatically validate and deploy not just the code, but actually a complex n-tier system running at scale and all that entails. So we're really excited about the reliability that's made possible by a rigorous test framework around blueprints. The final piece is the community catalog. So we'll shortly be announcing a place where all the blueprints that we've been working on and other people have been working on in various GitHub repos are not found by looking through the email list or coming to the IRC room, but by going to a community catalog.
There you go.
And that's where I think we'll see a sea change in innovation. It becomes so much easier to get those. We've already just completed, it'll be launched in the next version, integration with Salt and Ansible and Chef, Puppet's coming soon, and Docker images. So any of the most common ways to set up machines are easily incorporated into these more complex blueprints. So we can start to raise the game and create very interesting blueprints very easily from building on what's already out there.
So which speaks to then, the blueprint's really at the core here, of what we're talking about.
I think the blueprints are the core for the next couple years for most people. We never want to lose sight of the fact what we're interested in is the in-life management. Because if you can't do that, you've kind of missed the point of cloud. It's not just about starting something, it's about responding. So you want to make sure you can do the in-life management, but trying to do that management without a good model is a mug's game. We've seen people try to jury rig something that, okay, if this happens there, I've got this rule running up in this system over here that sees it, that pulls this lever, that launches this ball, that rolls down this hill, that hits this domino, and on a good day, the system recovers. That's not how we do management. So the blueprint is an easy way in to give us that model. It pays dividends now, and it unlocks really exciting automation possibilities.
And that is really one of the powers of the containers, right? Of containers themselves.
Containers accelerate that and just give us
Right.
even more things to play with.
Right, and then that speaks to the need for the networking requirements that will come, and and a lot of other things. But in the meantime, I think it's a healthy kind of focus on those blueprints themselves, right? Because combined with containers, then there's it opens up the doors to be able to think through really how you do microservices, right?
Yeah. Well, I think containers are a means to an end.
Yeah.
The blueprint is the end. That's
right.
the application that I want.
Right.
And the nice thing about the blueprint is the containers give me a way to run it really fast, and in some places that may be how I want to run in production. But a lot of times I'm going to have very different demands in production, but if I can use the same blueprint, I've tested it a whole lot further up the stack than I had when it was just a bunch of shells launching a bunch of containers.
And this plays very well, as you allude to, with Docker Swarm, for example.
It talks nicely to a Docker Swarm endpoint or a Marathon endpoint or a traditional cloud endpoint, or you give us a list of IP addresses. Our view, as I said, is to serve the application, not dictate how applications should be written, because that's not going to fit all applications. I think containers don't fit all applications.
No.
Cloud Foundry doesn't. So look at what platforms are right. Use containers where they make sense. You'd be a fool not to have that as a tool in your arsenal.
Right.
But equally, to think that everything's going to run on a container for 10 years is a choice people will be regretting within a year, I think.
Right now, it seems like the focus. I think one of the key points I think I came out of this hearing from you is about thinking about what is this kind of system you're building for your application architectures that you'll be able to change out, really, to replace, and that speaks to, I think, more so to the ephemeral nature of application components, right? And the ability to use components effectively in your application architecture, and that then speaks to kind of then the ability to have the freedom really to use services from an AWS or a Google Cloud or wherever it might be.
We're in a period of very rapid change and innovation in the platforms that we have.
Yeah.
So I think it's useful to kind of look out for them, use them where they definitely add value, but it's way too soon to try to get locked into one approach on the infrastructure side.
Right. Well, Alex, thank you very much for taking some time, to talk with us about, Cloudsoft and these concepts around automation and orchestration, and the ideas that I think are just beginning to really start to to emerge in the mainstream market. So this should be a fun year.
It's going to be a really fun year. Thank you for having me, Alex.
Great. Thanks, Alex.